So today we are doing problem 4-1 maximum XOR of two numbers in an array. So we got non-negative numbers with 32 bits and there is 2 times 10 to 5 to them, so we want linear log linear solution. So first hint, if you want to have, is trie. And now what do? We put the numbers in trie from most significant bit. And now what happens when we put in a new number, right? We first wanna check like what is the maximum XOR with that number. Since it's symmetric, you know, if we check for 10, doesn't matter, we don't check these numbers, because for all of them we will check maximum of that, which includes 10. So when we insert it, we will have a second node which will be the other number, right? And then what we would do is, if we can make the node have different bit, right? So at start, let's say one number has bit 1, like there is only numbers, or there is numbers with bits 1 and bits and some with bit 0, and then we get the number like, let's say 5, because that has the most, like bit 31 is 0, of course. So then we would see that how do I say this? We would pick a node, like we would our like DFS in the tree of the our other number should start with 1, unless there is no such number. And then we go down in the tree, right? And let's say what we are inserting has a 0, so we try to go to 1, and eventually we stop, or we shouldn't, but eventually we get some number, right? And that's the maximum XOR. I explained it absolutely horribly, but let's try. Self so there will be children, right? And then we do like root is node for num in nums, and then we want some sort of insert, so we get self node num, and then 4-bit in range if this happens, so we get the node, right? That's the starting bit, I guess, but we are in root. Okay, so basically this function wants to, what I'm thinking about right now is that we want to insert the number but also return the maximum XOR. But if there is nothing, we will not find anything, so wow, what a wonderful sentence, am I right? Other is node, and then we do num bit is num bit and 1, and now if other left or other right, first is and then we do if num bit, then we want to do if other c 0 if other 1 minus num bit, then other c1 minus num bit, else other c num bit, I guess. And now if first returns 0, we should store like other num is this, other num if 1 minus num bit other num plus equals 1 to bit, okay, otherwise other num XOR num. So basically we do somehow, and I'm not doing the insert. That's funny. If not node c num bit, then bit node c num bit node easy. So we create a node if it's there. I'm absolutely not explaining anything. This is horrific video, but basically this is the part where we just insert it, right? This part. First we get the other copy of the node, we check if this is even a first number, because if we immediately don't have any children, that's the first number. And then this is the number we are, like the other number that will produce the maximum XOR, right? And then we go from most significant bit, and then we insert it. If it doesn't exist, we create node to go there. And now ideally we want to go into opposite bit. If yes, we go there, and if it was like what we are building from the other number was true, then we add it to answer. Otherwise we go to same bit, and that's it. And there should be at all times because we insert 32 bits of each number, I guess. And then for each number we simply do like max XOR is equal our current XOR is self insert root, and then num ans if load attribute has if like this. Okay, that actually works for some reason. We'll see if it passes. Might get TLE because okay, so I'm somewhere here, so there is okay. Let's see discussion first. bitwise prefixes in hash set and in trie. So is this hash set thing just trie, but we add instead of tree we add everything to a hash map? Maybe that's why. That's true. Self MSB. I mean, I would have to find that out and I have to do a second pass for that, but fair enough. Self MSB. And then we do if num I and 1 okay, maybe this might be a bit faster, but I doubt it. Okay, same time complexity. Okay, I want to see the hash map thing because and so on and so forth. What? Returns check if current XOR could be done using 2. I mean, what is this thing? Why would you even do that, bro? Oh my god, dude. Hell nah. But this is interesting. Okay, so current XOR, you set that bit, compute all existing prefixes. That's fair enough. Update maxOR if those could resolve. So maxOR or with current XOR. Check if P1 P2 is equal to current XOR. In other words, current XOR P2 in prefixes. Nah, I mean, okay, but blah blah blah. Who cares? Fair enough. And then this okay, I mean that's the same. What do they mean by L and M? What is M? Log max. 212 is OM. What? Not sure about the time space complexity. Yeah. I mean, I saw this idea of bitwise trie a while ago, so that's why I knew it, but I mean, that prefix stuff is interesting, I guess. I don't know really what to call it, to be honest. So let's do bitwise trie on all numbers try starting from bit. First, let's put all numbers with 0 bits to make them same length. Then we just make a trie of the binary representations starting from bit to bit 0. Each time we insert a number, we will also simultaneously the other number that will make up the maximum that is the maximum XOR with none. Can do that by trying to find going in the existing trie down a path with ideally opposite bits. For example, when we insert 5, we want to first find numbers 0. Then from that node we find numbers with starting with blah blah blah. If we cannot make our move, i.e. there is no number with the required prefix, we simply pick the same bit value ON since I mean the trie space complexity is for sure not O1, bro. It's for sure not O1. I don't believe that one bit. One bit, I don't believe that, bro. Since each number takes all 32 OLN to insert if we pretend L is a constant, since we just go down the trie with two nodes ON since we insert okay, I guess I mean horrific explanation and code, but maybe you got something from this video. See you tomorrow.